we had created a program that would use Monte Carlo integration in order to calculate the integral of e to the minus x over the region of 0 to 1. This worked. However, it wasn't a terribly useful program as we wrote it. It would only calculate the integral from e to the minus x. And that's not what you want to write. You want to write code that's usable for more things, so you don't have to rewrite it every time. So let's look in part 2 here and see how we can improve this function. So just to recap, we compile our code. And eventually it will come up. We can do 16 iterations of 3,200 guesses, calculate it. We get an integral value of 0.63214 compared to the actual value of 0.63212. Very good, this works. But like I said, it isn't very useful. So, how do we improve it? How do we make it better? Well, the first thing we're going to do is take our function that actually does the integration, and this function just works by calculating a large number of random values, taking the average of that function, and then multiplying by the volume in one-dimensional space, which in this case was 1 because 1 minus 0 is 1. To get our integral. So let's remove this and let's create a new file, a Swift file, and we'll call it Monte Carlo Integration. I can paste now our calling function into here. We'll tab this over. All right. And then we're missing that function there, so I've left one extra here. So there we go. That should take care of that. All right. So now we have a file, Monte Carlo integration, that theoretically could be moved over into any project that we want to do the Monte Carlo calculation. So right now, we're limited to dimensions equal to 1 because we only had e to the x. So now we're going to expand that, so there's really no reason to leave that. So we can get rid of our if dimensions equals 1, because we certainly want this to work beyond 1 dimension. All right, so let's start with that. But now, because we want it to work with more than 1 dimension, we need another for loop. So we have to have a for loop over the dimensions. So for j in 0 less than dimensions, we're going to want to create a random number for every variable in the dimensions. So I put that in there. But this is going to, right now, just overwrite x for the number of times that we have in dimensions. So that's not terribly useful. So we want to create a new variable up here, parameters. And we'll want that to be an array of doubles. And we'll populate it with an empty set to start. And instead of letting x be equal to this value, we're going to append this value into parameters. So we'll have parameters dot append double dot random. And we'll populate one value of parameter for every dimension. And in the current integral, we don't want to calculate e to the minus x. We could right now, but we're not going to want to do that. And so the best thing for us to do is to come up with a way to allow us to pass in the function that we want to calculate rather than just e to the x. One way to do that is to create an alias to a function. So we can make a type alias, and the type will be integration function handler. And so we want a function that will return a double like e to the minus x does, but that takes a varying set of parameters. So we're going to say our integration function handler will return us a number of dimensions, or we'll take a number of dimensions as input, number of dimensions, and that's going to be an integer. And then we're going to have an array of inputs that we can use to calculate the value of the function. And so that's going to be an array of doubles. Then we want this function to return a double. Oh, and yeah, left out the underscore there, so we need to put the underscore in there. The underscore basically just tells us that the array of inputs and number of dimensions don't need to show up. It's good to have them listed out here because it improves the readability. But when we have this type alias, we can use this for multiple things. So now I can create a new function down here, function, and we'll call it e to the minus x. And e to the minus x has to match the type function handler. So it's going to take input as number of dimensions and array of inputs, and it's going to return a double. All right, so this function now needs to be checked for the number of dimensions. So if number of dimensions is equal to 1, then we actually want it to calculate e to the minus x. So we're going to say return exp minus array of inputs. And since it will only have a single value, we'll put 0 to grab the first value. Else, we should print an error message. The dimensions do not match for 1D e to the minus x. So that tells us what the error is. This makes sense. This function always has to return something, so we'll have it return 0.0 in case we get to this point and it does not give us a valid integral. Okay, now I have a function that's being used, but I haven't passed it into my integration function yet. So I have to add up in here another parameter of the function, and we'll call it function to be integrated. And that has to be an integration function handler. Then my current integral gets replaced with e to the minus x with function to be integrated. And then we have to pass to it dimensions and parameters. Now I get a couple warnings right off the bat. Immutable value I was never used. Immutable value j was never used. Normally we would want to take care of these warnings, but I'm going to leave them for the time being because we do want to use these values later. Right now we're still limited to an integration from 0 to 1 because we've got those values hard-coded in here. That's still not great, but we'll start with this and go on. Now, if I wanted to, I could add a couple of other functions as well. And I may as well do that right now while I'm here. So I'm going to copy e to the minus x. I'm going to make a function e to the x. So I can integrate e to the x by just getting rid of this minus sign here. It still has to have one dimension. Now I can make another function, 10d integral, and it again has to match with our alias, our integration function handler. But this function is going to be a little different. It won't have one dimensions. It'll have 10. So if my number of dimensions is equal to 10, now I have to do something. And so in this case, I'm going to make the function that I integrate be equal to x1, that's x0, plus x1, plus x2, plus x3, plus x4, plus x5, plus x6, plus x7, plus x8, plus x9, and we'll total this value up, and then we're going to square this function. So I'm going to say let total equal to array of inputs dot reduce 0, comma plus. What the reduce function does is it takes all the elements in an array and sums them together. So this is effectively a for loop that iterates over all the elements of the array and then sums them. Once I have that value, I can then square it and return it. But All right, so I've got that. And then I have to have an else statement. And if I don't have the condition of 10 dimensions, I'm going to print an error. Say the dimensions of the 10D integration were not equal to 10. Pass an error message. In this case, we'll return, just as we did last time, 0.0. And then up here, if we get a value for total, we need to return power of total and 2.0. So that will return total squared. So now we have three functions that we could actually integrate. And that's a good thing. This is a much more useful function, a much more usable function. And that's what we're trying to write in our classes. We're trying to use functions that are reusable over and over and over again, so we don't have to rewrite these things. All right, so now we're going to find we have a little bit of a problem. So let me save this function. Come back in here into our view controller. And if I compile and run this, we're going to fail. And it's going to file with the error. There's a missing argument for the parameter function to be integrated. So I can go ahead and fix that and tell it I have to include in the call to calculate Monte Carlo integral the function to be integrated. Now if I want, I can quickly just put in e to the minus x here. And if I do that, I really don't need to include this. I can just pass e to the minus x like that. In this case, I should exactly match up what we had the last time. So let's build it and run it. So if I were to put in 16 for the number of iterations, 3200, and hit integrate, I get 0.676, and that wasn't as good as what we had last time. Let me run it again. And now I get 0.617. I run it again. I get 0.599. Okay, that's odd. Something must be happening here. So how can we look at this? Well, one thing we can do is come in here and print out what the individual integral values are. So I'll print the integral value array and go ahead and do this. We could use the debugger to check this value too, but it's faster to just print it out. So if I do 16, 32, hit integrate, I see that these values are all over the place. 0.89, 0.374, 0.742, 0.41. And while the integral itself isn't too far off, the average of all these, 0.6217, there's clearly something wrong with the code. And so we've made a mistake here. So we have to figure out what error we actually did. So the only thing we've changed was really in the Monte Carlo integration. So it has to be something here. So if I look at the function e to the minus x, it is returning e to the minus x. Can't be anything wrong with that, so it's got to be something else. So what was the other thing we did? We added in the dimensions and the parameters. So if I go var parameters double equals an array, I go through this and I append parameters, some random number, calculate the integral passing on the parameters. I take the first value of this, I loop through again, create and append another random number. Oops! When I go to parameters here, I'm now passing in a function with two parameters, two values in the array, and it's only taking the first one. This is a problem. That's not what I want it to actually do. I want it to take the second value. But I don't really need to pass multiple values, and I don't really need to keep using these things over and over and over again. So what I really want to do is remove everything from parameters after I go through this integral. So I want to do parameters.remove all. Now when we do this, every time I go through, I remove the parameter and I only have one value to pass on every time. So now if we rebuild this and we say 16 iterations, 3,200 guesses, hit integrate, we now get 0.63303 versus 0.63212. We integrate again, we integrate again. But now if we look at all the values, they're all very close. We don't have any widely varying parameters. So that was important because we don't want to make mistakes like that. That's not a helpful mistake to make. So you always have to make sure that you check these things as you go forward. All right, so now that's great. I can calculate e to the x. Okay, well, in this case, e to the minus x. But I can't change the functions that I actually create. So how can I do better and make it so I can actually change these values? Well, one thing I can do is to go back to my storyboard and I can slide these things over. And I can add a combo box from which I can select the different items in the box. And I also want to add a title, so we can come up here and we will go with function label. There we go, label. And our label will be function to integrate. Go, that looks good. Now right now this function box, this combo box, is populated with item 1, item 2, item 3. We could change those to be the values of our functions, but I'm not going to do that here. I'm going to do that programmatically. So let's connect the box up into our view controller. And so we may as well call this, what are we going to call this? Function. Function selection, how's that? Actually, I'm going to undo that real quick. Because I think we have actually wired it up to the wrong thing, so I'm going to rewire it up. There we go. Yeah. That's better. Pop-up button. All right. Now I'm going to wire that up. View controller. Just delete that. All right. Call that the selection function. All right, that's better. Okay. So now we have our selection function. Now, when we first call our view, when we start, and this view did load, we want to do any additional setup. And the setup we want to do is actually remove everything from the function selection. The selection function, that's the selection function, dot remove all. So we'll remove all the items from that. Then we want to populate it programmatically. Selection function, dot add items. And we'll give it an array of strings, where we'll have e to the x, e to the minus x, and 10D integral. So now, when we run this, let's add items with titles. All right, there we go, and add items. There we go. Add items with titles. Okay. We run this. And now we have our button that's populated with our functions. But it doesn't do anything when I select these. That's a little bit of a problem, but we haven't coded that in yet. So now we need to add in a function that will pick what to actually do based upon which one we select. So to do this, we have to go back to our storyboard and add an action to that button. So we're going to add an action that basically selects the function. All right, so what do we need in this function? What does it have to do? So it needs to take the input and switch these values. So we're going to go switch function, or well, what do I call that? Selection function. So it's going to switch on selection function. I don't need this anymore, so I may as well open that up. Based on the title of the selected item. Then I'll have a number of case statements in here. The first one will be if I have e to the x. I'll have another case for what to do if I have 10D integral. Have another case for e to the minus x. And I always have to have a default case. All right. So what do I need to do when I get to this? And by adding in these values, it will actually help me to address these errors that I get. Well, I know in this case I want to set dimensions to be equal to 1. And if I'm interested, I know what the exact value of this integral has to be. And so that's going to be exp of 1.0 minus exp of 0.0. For the 10D integral, I know dimensions has to be equal to 10. I know the exact value of the 10D integral in this case is 155.0 divided by 6.0. For e to the minus x, I know dimensions has to be equal to 1. The exact value in this case is going to be equal to negative exp to the negative 1.0 plus exp of 0. But I haven't told it what function I need to use yet, and that's a bit of a problem. So how do I want to tell it which function has to be used in the calculation? Now in that case, I'm going to have to create a new variable. And so I have to have a variable that basically tells it what function to actually utilize. So this function or variable has to be of the type integration function handler. So I can have a variable and that will be function for integration. Type integration function handler, and I'll have it default to be e to the minus x. So if I get down here, I'm going to set function for integration equal to e to the x. If I get down here, it's going to be function for integration equals 10D I don't remember what I called that, so let's go look in the file. That one is 10D integral. There we go. And that's because you can't start a function name with a number. And down here will be function for integration equals e to the minus x. For the default, since I'd already set it to be the minus x, I'll just copy this over. So now we have a method to select our function. We know what it'll calculate. But right now we've got hard-coded in here and our function for the integration. Our function to be integrated is e to the minus x. So we actually want to change that. We don't want it to be e to the minus x every time. We want it to actually be the value that we select in function for integration. So let's make that function for integration. And so there's one other thing that we actually would like to do. Well, we already do. We print out self.exact, so we're in good shape already. So now we can just go ahead and run this. So if I set my function to e to the minus x, do 16 iterations, 3,200 guesses, and integrate, I should get 0.63249 compared to the exact value 0.63212. If I integrate this a few times, I see I get very good results. If I change it to e to the x and integrate that, I get 1.719 compared to 1.718, so this works very well as well. And if I change it to the 10D integral and integrate, this takes longer, and we have an error, obviously. So the dimensions of the 10D integration were not equal to 10. Okay, so now we have to figure out why that is incorrect. We can see the exact integral should be 25.8333, but let's go ahead and fix this error now. So there in the 10D integral, I have dimensions is equal to 10. So that seems reasonable. If dimensions is equal to 10, well, that's interesting. Dimensions, the 10D integral were not equal to 10. Oh, I love errors. Well, let's see why. So let's go ahead there, print number of dimensions. And so it thinks the number of dimensions is equal to 1. Let's just make sure. 32, number of guesses. I want to do 16 there. The number of dimensions is equal to 1. Outstanding. So, oh, I know why. Yep. Sneakily, we hard-coded not just the function, but we also hard-coded in the number of dimensions. So there we had dimensions hard-coded into 1, and we need to pass instead dimensions. Now if we rebuild this, it's got to be an int. Fix that error, now rebuild it, because it was an int 32 and it needed to be an int. So we'll go 16 iterations, number of guesses, 10D integral, and we get 25.877 compared to 25.833. We can integrate it again. Now this is not as good because we're sharing our small number of guesses over 10 dimensions instead of over 1 dimension. So if we want to do better for this, we have to increase the number of guesses. We can integrate that. It will take longer, obviously. Especially with it printing out 10 dimensions 100,000 times. Print statements are very slow. You don't want to use them if you don't need to. And in fact, that's going to be so slow, I'm going to kill it and take that out. So let's get rid of that. Now it will run much faster. (16, 3201, 10D integral, integrate. So we can see it's now started the number of threads, and now it's completed. So we got 25.827 is compared to 25.833. So that's not too bad. Now, we've gotten a much more usable function by doing it this way. And that's a good step. But we haven't gotten any unit testing as of yet. And we haven't well commented. We may not have the greatest of all variable names. These are all things that we can continue to address. The other thing that we haven't done at all was to add in the ability to have any type of integration limits. And that's a major flaw. So we will want to fix the number of variables that we can integrate over. We would like to be able to integrate not just from 0 to 1, but from -5 to 372 if we want to. And so that's something that we actually have to do and have to address as well going forward. So there are a number of these things that we're missing right now, and we really, really, really need to do a little bit better in this.